reactions are exothermic reactions where heat and light are given off. The other side of that are endothermic reactions where heat is absorbed. So I'm going to demonstrate that today. So this is an endothermic reaction, and it's also a kind of rare reaction because it involves the reaction of two solids, and we'll get that to go. So I've got the two solids in there, and now I'm going to mix them up. One of the products of this reaction is liquid water, and so what happens is we then form a kind of slurry in here of the substances in that slurry of liquid water. Now this gets extremely cold, and in fact it gets cold enough that this will freeze to a block of wood. So I'm putting some water on this piece of filter paper, then I'll put the flask on that. This takes about 30 seconds to a minute to freeze. While it's doing that, let's come over here and do a little demonstration involving electricity and electric circuits and a little known property of glass. So I have here two bulbs that are connected in series. So the electricity has to go through both bulbs. If I unscrew one, the other one goes out. If I unscrew this one, the first one goes out. So they both have to be working for light. Well, what I'm going to do first to safety plug that in there is take one of the light bulbs, wrap it in some paper toweling here, get it wrapped in the paper toweling, then I'll use my pliers to break up that light bulb, to break it. Now I'll use the pliers themselves to break off the little pieces of glass so I don't cut myself. Got that done. Now I'll use the side cutters on the pliers to cut off the wires that would held up the filament. And now I'm just going to screw that broken bulb back into the socket there. Well, one of the little known properties of glass is that when glass is in the molten state, it becomes a semiconductor, and it actually will conduct electricity. So I'm going to be heating up that broken light bulb with this propane torch. We'll get that heated up carefully, and then when I get that to the molten state, you'll notice what happens. The glass actually becomes a semiconductor and will conduct electricity. But we've got it almost up to that point there where it is hot enough to conduct electricity, and that should be conducting the electricity momentarily, unless we've broken some other things.
It's not plugged back in yet.
This demonstration almost always works.
It's not plugged back in.
I'm not sure what happened there. I'm sorry about that.
It's not plugged in, Rubin.
What?
I don't think it's plugged in.
Oh, it isn't plugged in. Well, let's go back and plug it in and keep that. Thank you, John. That's a minor problem. I was being so safe I didn't plug that in. It would help to plug it in, and let's heat that up again, and there we go. Okay, so we actually have that and let's come back here, and you can see that that's actually frozen to the block of wood. I'll clamp it up here. You can look at it from time to time. This will actually stay frozen for at least half an hour. John?
Well,